Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this specific video we will be starting our another boosting algorithm. So if you remember, till so far we have covered up two boosting algorithms in our ensemble techniques module. What are those? So let me remind you, we have talked about EDA boost in a very great detail, followed by we have also discussed about gradient boosting. Today's discussion, you can say, is an extension of what we have covered up in our gradient boosting algorithm. The full form of XGBoost is extreme gradient boosting. So, by the full form itself, I think you will be able to get an idea that somehow it's a conversation with respect to what we have learned in gradient boosting. And on top of that, there will be few extra things that we need to understand. This algorithm is one of the most powerful algorithm. So please make sure that you will watch this specific modules video very carefully. Document your learning properly, because you will observe that in industries, in various complex data sets where the other machine learning algorithms are not performing well, this is performing superb. So it gives amazing results because of the pros of this algorithm that we have, which we will cover up in this today's session. So today's session is completely dedicated towards what are the advantages of this algorithm, why this is so powerful and very famous algorithm in machine learning, and what is the beauty about this, because of which many ML algorithms are failing with respect to complex data, but it is behaving strongly in that scenario as well. So it's one of the crucial session. Please make sure you will watch it till the very end and document it step by step, whatever things I'm trying to convey here. With this, let's get started. So now let's take the point step by step, and we will try to understand that why this algorithm is really amazing and really powerful. The very first thing which is the beauty about this algorithm is its distributed computing power. Now, I'm not sure that how many of you will understand the literal meaning of distributed computing, but let me try to explain you in a very layman manner. Uh, let's suppose we will be having a very large data set. So, what will happen is, with respect to that large data, we can use multiple machines, and parallelly we can do the computation. So, parallelization or parallel, you can say, computation is being done, right? And that is why it will be able to give us the results very fastly. The complete tech stack of big data, if you are aware, if you are someone who is from data engineering background, belongs to the concept of distributed computing only. That at any point of time, if we will be having a big data, there is a concept of Hadoop, internal, if you will see, MapReduce. All these things are based on how the distributed computing works internally, right? So the literal meaning of distributed computing is that across multiple machines, if let's say we will be having a large data, we can parallelly do the computation, training, and will be able to get the results much faster as comparable to other machine learning algorithms. And that's the one of the biggest reason, I would say, because in real time scenarios, definitely majority of the time you will be dealing with a huge amount of data. So that's number one thing. Number two, it supports a concept of early stopping. Now this is also one of the most interesting concept, early stopping. What is the meaning of early stopping? See, at every point of time, whenever you are doing a training, it will try to keep a check of the, validation set. It will try to keep a check of validation, or you will see in the upcoming module when I'll talk about the cross validation techniques. Usually we try to split our data set into two parts, right? Training and testing. Further, the train set we can split into train and validation. This is basically used to avoid the overfitting. So what will happen is, as soon as you are training your model, it will observe that at every point of time, the training error and the validation error, it should be decreasing, right? At every point of time, whenever you are doing a training, both of the errors at every point of time, as soon as you're increasing the training, it should decrease. But after some point of time, when there is a overfitting, so it is basically used to prevent the overfitting. So there comes a time where you will observe that, somehow the training error is still reducing, but validation error somehow is not reducing. It is increasing abruptly. So that is where it has basically helped us to prevent the overfitting. And that's a technique which we call as early stopping. So what I'm trying to convey here is that, let's suppose you will be having a data. So here you are trying to train the model. So training is going on, and here we will be having an error. So what usually happens is that initially when you will be having you're starting your iteration, error might be very, very high because your model is not trained well, right? Now, as soon as you will try to increase this thing, training part, iterations part, your model is training, what will happen is your training error should keep on decreasing. That's the complete idea. That's why we are doing multiple iterations, right? So it is going like this. So this is something which I will say it as a train error. So it will keep on decreasing. Now what will happen? You will be having a validation error also, which will keep on decreasing. But after some point of time, you will see there is an abrupt change, that this error starts increasing. So this is the point where my validation set, this is the, let's say, validation error we are talking about. So this is the point where we are saying that our training error is also low at the lowest peak, and validation error is also low. After that, training error is still decreasing, but validation error is somehow increasing, which is a situation of, after this, if you will just keep on doing a training, this is a situation of overfitting. And definitely we need to avoid this situation. That is where what early stopping will do. Early stopping ultimately check it out that on which iteration my validation error is the minimum, and after which it starts increasing somehow. So it will stop your training at that moment itself. I hope this point is pretty much clear. And again, in practical real-time scenarios, we use this technique to avoid the overfitting part. Third interesting thing which this model is having is the ability to handle missing data points. So you all know that in EDA, it's a very crucial step to check that how many data points are missing, and then there is a need to tackle those missing data points that we have. So what usually happens is in the XGBoost algorithm, it internally tries to do a best imputation, I would say, to tackle the missing data values pretty well. So it will be easily able to handle that data imputation part in such a way that we will be able to at the end of the day, don't deal with manually missing data points that we have. Apart from this, you will observe that there is something called as XGB tree that we will try to, curate here. It's similar to, I would say, decision tree, but it's not exactly same. And when you will try to curate this XGB tree, you will be able to see it automatically does the pruning of that with one parameter, which we will discuss, gamma and lambda, 2 parameters in this XGBoost algorithm. Both of them we will discuss. So there is a parameter which we will have to hyperparameter tuning we have to do, and then pruning will happen. So this is again able to avoid the overfitting. So basically this tree, if we will be able to tackle the parameter pretty well, pruning will be done. And this will basically help my model to make an optimal maximum depth of a tree so that overfitting will not be there. Now, the next important point is the regularization parameter. The very important thing, again, as I told you, there are 2 parameters, regularization parameter. So one parameter which I'm talking about for pruning part is gamma that we will see. And this is a parameter which we call as lambda. So both of the parameters we will discuss in detail, that how it will be able to handle the regularization, again, to avoid the overfitting part. So all in all, you will be able to observe that if we are applying XGBoost algorithm, internally there are so many metrics that methods we have which will help my model to prevent the overfitting problem, and will be able to tackle the large data pretty well, able to handle the missing values pretty well. Distributed computing is there, which is basically helping in the speed part to get a better, accuracy in a very small number of time. Means training will be done very, very faster. And the last interesting thing which I want to talk about with respect to this model is its compatibility. One important thing which you will observe that this XGBoost model is not a part of sklearn. For example, usually whenever we are trying to call any algorithm, we usually call from sklearn. For example, sklearn.ensemble, we are importing random forest classifier, or we are importing gradient boosting regressor, random forest regressor. But with respect to this XGBoost algorithm part, let me just try to showcase you what I'm trying to convey here. So let me just open my Google Chrome. And here, one thing which you will observe, if I'll just open the documentation of XGBoost, so you will see it's not a part internally inside the sklearn. It's a separate documentation which you will be able to see. And when I'm saying compatibility, you can see that this specific algorithm is available in Python, R, JVM, Ruby, Swift, Julia, C, C++. Means you can name the famous programming languages that we have, and in all the programming languages this package is available. It means that it is really compatible with respect to different programming languages that we have. So that's the another beauty about this specific algorithm that we have. So all these things combining together makes this algorithm, you can say, really powerful. This algorithm is really powerful in the sense that maximum number of times in a real time projects, and even if you are dealing with any of the, I would say, Kaggle competitions, if you are participating, or hackathons, right, you can give a try. As I always say, random forest is the one, and second one I always prefer is XGBoost. Chances are very high that it will be able to give you a better performance because of its features that we have just now discussed. Now, in the next upcoming session, I will discuss about the maths behind this algorithm. For example, we have talked about this XGB tree, where pruning is being done. So we will discuss that how this XGB tree will be created, what's the maths behind that. We will see what is this regularization parameter and where it is being there, and how basically we need to handle that. Similarly, there are multiple things we will see in terms of doing a model training and model prediction part. So a lot of maths is there, which we will discuss in the upcoming session. So stay tuned, and I will see you all in the upcoming videos. Bye bye everyone, and see ya.